So the only thing that you're going to need to install is Node.js on whatever computer you're using. Everything else you can do from any IDE, because the only work that we're going to do is programming with JavaScript, which is just writing files with whatever IDE you want, and also working with the terminal a little bit with some very basic commands. So let me see if I can find the right website for you guys, just so that you know you're on the right place. I think you can download Node from there, and it will probably walk you through a command line installation. And once you finish with that, you will have Node installed, and you'll also be able to use the Node Package Manager, which is how you manage JavaScript libraries. If you are not super comfortable with the concept of Node or NPM, that is just fine. We're not going to do anything complex. VS Code is absolutely okay. I use VS Code for basically everything I do nowadays. It's excellent for web. Hi, everyone. My name is Eli. I am the project's co-director at Nighthacks, the other co-director being Samit, who's running a workshop tomorrow. And I'm here to talk to you guys about React.js, which is a framework for working with front-end development. And we're going to explain why you might be interested in React and what you can do with it. All right, so a brief outline of what we're going to talk about. First, we're going to talk about what is React.js and why bother with it. And then we're going to move into components in JSX, which is how you describe rendering. And then talk about some other important things, props and states. And then hopefully spend as much time as we can on the demo at the very end, so you guys can see what putting it all into practice looks like. And then at the end, I'll give you a couple of helpful links, and we'll have as much time as possible for questions and answers if there are any. If questions do come up in the middle of a slide, please just go ahead and write them. I will try and answer as much as I can. If it's a really, really long question, maybe hold it until the end. I will spend as much time as possible answering questions, and any questions I can't get to during the session, you can certainly ask me over Discord afterwards. Okay, so let's jump right into it. The first question becomes, what is React? And React is a JavaScript framework for creating web apps. It was created by Jordan Walk at Facebook in 2013, so it's had plenty of time to develop. And by framework, all we mean is a set of libraries that simplify the web development process. So if you're writing every single thing that your website needs to do by hand, and everything you're doing is made up of tags that you're writing, then you're reinventing the wheel that people have done all the time. And you're doing way more work than actually needs in order to get a website up and running. React helps simplify that a lot, and especially is useful if you're working on a time budget. It takes away lots of the stuff that happens behind the scenes so that you can focus on just what's important to your application. And the nice thing about React is that you can use as much or as little of it in your UI as you want. If you have a fully HTML, CSS, and JavaScript website already built and you just want to add new features in React, you can absolutely do that. Or if you want to start from scratch, you can write your entire website in React. It's however much React you want to use, that's exactly how much you need to use. Another thing you might have heard of is React Native, and they are very similar. They're both JavaScript frameworks, and they are both created by the same organization, but they work for different platforms. So React.js is designed for making web apps on any browser that you want to use, and React Native is for creating mobile applications, also with JavaScript. React absolutely came first. They're very, very similar, though. A lot of the logic is exactly the same, but the difference becomes what components you're putting inside of your React Native applications. For React Native, we have lots of elements that describe things on your screen, like text or images or scrolls, like scroll bars. Whereas with React.js, we use exclusively HTML tags because everything in the end gets boiled down into HTML, or document object module, which we're going to abbreviate as DOM for the rest of the presentation. Essentially, it all gets boiled down into HTML. In terms of the benefits of using React, it reduces the amount of code that you have to write for really powerful web applications. Again, lots of things have already been done by lots of people. You can easily plug and play different things that people have come up with. You can reuse components that you've already made for other purposes. You don't have to rewrite them. And also, it just simplifies the amount of code that you need to write in order to make something really powerful. The big thing about React is that it re-renders your page when data changes inside of it. And it doesn't re-render the entire thing. It only re-renders pieces that are related to the state update. And by state update, we mean some piece of data in one of your components changes, well, that component now has a different state. And so React is smart enough to know I need to refresh this specific item and all of the related elements inside of it, and only these items. So it's not going to refresh your entire page. You don't have to do a full reload, which would take a lot of time. Rather, it can only refresh what's important to React. The other nice thing is it's a very simple and easy to pick up syntax. Everything you write is going to be a component. And once you understand what components are and the syntax for them, the question becomes what you're going to put in it. Another nice thing is that it helps to encapsulate data and actions into components. So instead of having lots of different elements that have to figure out what other elements they need to interact with, we can sort of bundle everything up into a component which has related features to it. And eventually, it will render all the way down into the HTML elements, the same as if we had created our website with lots more code from scratch. And then the final thing is that it helps keep component logic and rendering details entirely in JavaScript. So you don't have to write any pure HTML or CSS if you don't want to. All right, so what we said here is that our React page has to have a root component, which the DOM is going to essentially make a container for all of our other components. And everything goes inside in a hierarchy tree. So this snippet is exactly what we have to write to specify to an HTML page. Okay, this is our React root. And we're just going to apply this for the rest of the presentation. We're not going to write it in every single code snippet because we don't really need to do that. Just know that this is something that happens and it happens once. And then moving on to components, we can also have lots of different components that do different things. So there's two ways of creating components. We can either create a class component, which if you worked with any object-oriented language before, you know what a class is. It's simply a JavaScript class where we can create instances of it, create objects, and do things with those objects. This is sort of legacy React syntax. We don't really use this anymore for reasons I'll describe in just a second. But we have to import React from this top line up here in order for our application to know, well, what is React and what is a React.component? So we're also going to imply this snippet. React is an NPM package, which is why we're going to need Node when we get to the demo and when we actually start writing our React applications. So we'll get to that later on. One thing to note about components is that you are only required to return a render method. And that render method is telling React, okay, what do I need to render in place of this component in the end? So we can introduce lots of logic to our component that changes how we determine what that render is. For this, all we're rendering is a static div, which is basically a container, and then a header, and then a paragraph. And that never changes. So that's not really anything super useful. But eventually, we'll learn about other ways that we can introduce logic into our components so that we can determine what are we going to render this time, or what are we going to render this other time, and things like that. So you only need a render method, but we're going to include much more than that. So like I was saying, there's two ways of creating components. You can use a class component, which is a JavaScript class and extends React.components. And in this case, if we want to pass in data to our component, we do it through the constructor of the class. And what we're rendering is determined by a render function that we have to provide for our class. This form can be a little bit more clear for people that maybe aren't familiar with JavaScript but are familiar with other object-oriented languages. Usually classes are a little bit easier to understand. But it's also just kind of legacy. People don't really use this anymore. So instead, what we typically use is functional components. Functional components are much in a more recent version of React, and it's functions, JavaScript functions, that return what we want to render from them. So instead of having a constructor, we pass properties into the arguments of the function. And the function can declare variables and functions inside of itself to determine what we're going to render. The rendered output is whatever's going to be returned by the function. So we don't include a render method. Simply, we just return our tree of things that we're going to render. And again, we don't really use class components anymore. So for the rest of this presentation, we're going to stick with functional components. We can also, if any of you guys are familiar with JavaScript enough to know about anonymous functions, this picture that we have over here is a standard JavaScript function. It has the function keyword, and then the name of our function, our parameters, and then the logic inside of it. An anonymous function is somewhat different. So if we skip ahead a little bit, this is how we define an anonymous function. essentially, we create a function that doesn't have a name. So it simply has arguments, and then it has logic inside of it, and we assign the reference of this function to a variable. And so now we can call that variable in place of our function reference, which isn't named. It's a little bit complicated to think about, but think of it as it works exactly the same as a normal function. It's just a little bit of a different syntax where we don't have to write the word function every time. So let me just make sure there's nothing else I wanted to cover here. This is the exact same example as we had on this slide over here, where we're just rendering a div and a header and a paragraph. And in this case, all we're doing is using the return value of our function and our tree of components. So inside of a functional component, we can do anything that we could do inside of a normal JavaScript function. We can declare variables, we can declare other functions, and then eventually we return a value out of it. We'll talk about more of all of this later. This is a little bit more involved example here. In this example, what we're doing is we're creating a button where when we click our button, it calls a function. And what it's going to call is our handle click function. So we've stored a reference to this JavaScript function inside this variable. And so when our button is clicked, we call the function stored in handle click, which creates an alert on the browser, which is what we see down here. And we also have a couple of other elements in here that we're going to do some fancy stuff with. The syntax may not look anything intelligible to you guys, or it might be very simple to understand. I don't know where you're at, but we're going to cover all of it by the end of this. So if you're lost, don't worry about it. Okay, and then another question is, can I render a component inside of another component? And the answer is yes, absolutely, and please do. The primary design pattern of React is composition. So if you work with normal object-oriented languages, oftentimes you'll have inheritance, which means you have a parent component and it basically passes down properties to another component or object that inherits those properties. React doesn't really do that. Instead, what we do is we compose components of other components, which lets React know if that it has to re-render a parent, it also has to re-render everything inside of it. So it makes a lot of logical sense for what React is trying to do. So here's an example of how we're doing that. In our previous examples, all we had done is create a component of HTML elements. Like here, what we're going to do is instead of creating a paragraph element here, we're just going to substitute another React component. So our React component does the exact same thing where it has a button, and if we click the button, it calls the function stored here. And we simply take this component and stick it right inside, right underneath the header element. So this is our header element outside, and then this is our other component, which is right below it. All right, so the next thing to talk about is JSX. And JSX is essentially the way that we describe to React what it needs to render for a particular component. You've already seen it because it's what we put inside of all of our renders, all of our returns. It's very, very similar in structure to something like XML or HTML. So if this looked normal to you, then it's because it works the same way. You have different tags and you put them inside of other tags. JSX is a little bit more flexible though. And also note that you are not required to use JSX. If we went back all the way to our initial slide where we talked about putting a root element, and we had our method of React.dom.render, and then we put a component in there and specified a tag, and it was this long, long syntax just to render a single component into our HTML page. We could do that for every single component, which would be awful, or we could just compose components like this through JSX, and it's much cleaner and a lot easier to work with. So there's a couple of rules that we have to abide by with JSX that we normally wouldn't have to do with something like HTML or XML. We're going to talk about these one by one. So the first one that we want to talk about is that JSX expressions can only have one parent element. So in this top example here, we have 3 elements at the top level of our return. We can't do that. Instead, what we need to do is we need to come up with one element at the top level and put all of our other elements inside of it. And so we could do that by simply using a div. In regards to HTML, a div by itself is just a container. It doesn't have any special stylings on it. It just is the size that it needs to be to hold everything that's inside of it. So if we just create a div element and don't put anything special on it, then it's essentially invisible and we get a container for free. So usually if you don't want to introduce another element as the parent, it's usually safe to put a blank div in there. But if you have another container element you want to use, or you want to fancy up that div a little bit, you can absolutely do that. Okay, another thing to think about is that some of our properties work different in JSX comparatively to they would in base HTML. So if we wanted to create a style property for an HTML element, which is what we're doing over here, our style property takes a string. All of our properties in HTML are required to be strings. So we can specify the name of the property, which in this case, we're going to go with the background color property, a colon to say, OK, now we're moving on to the value, and then our actual value. And if we had more properties tagged onto the style tag, then we would want to put a semicolon and then some more style properties after that. And so we're not actually including the layout of this contact card inside of this HTML tag, which I now realize was a mistake. Essentially, what this is doing is it's taking our React component that I wrote in an example off the screen, and it's inserting it into the root element here. But the important thing to note is just that the style tag in HTML takes a string, and it has this particular format. If we did the exact same example over here, where we're doing it entirely in React and JSX this time, our style element works differently. Style, in this particular case, uses a JavaScript object. And you'll notice that we have two sets of curly braces, and then we have a bunch of things in here. So again, if you're not super familiar with JavaScript, this isn't going to make a whole lot of sense to you. But what we're doing here essentially is we're wrapping our JavaScript object, which is this white curly brace and everything enclosed in it, inside of another set of curly braces. JSX, by default, assumes that everything is going to be a tag until you tell it otherwise. If we can insert JavaScript anywhere into our JSX that we want to. But in order to do that, we have to wrap it with a set of curly braces so that it knows, OK, this is JavaScript code, execute it like JavaScript. So essentially what we're doing here is this blue curly brace is saying, OK, everything inside of here is JavaScript. And then we're creating an object literal, which means we're not creating a class and then calling new that class to create an object. We're just going to define it in line. And our object isn't of a particular type. It simply has these properties, and they have these values. So you'll notice a couple of other things important here is that we don't use hyphens for style properties anymore. On the previous example, background color had a hyphen here. But here, it's camel case. So any property that you put inside of a style tag is going to be camel case instead of hyphenated. And also, you'll notice that we have a number here. These numbers have a default unit attributed to them. For margin, it's pixels. For other things, it might be different. But we could specify this as a string 5 pixels as well, and it would do the exact same thing. OK, that's a lot to handle. The important thing here is really just that properties work differently in JSX than they do in HTML. If you're worried about if something is going to work the right way, usually your compiler will be smart enough to tell you whether it's going to or not. If it's not, you can always look on the React documentation, and it will tell you what the differences are. OK, third thing is that we can write JavaScript in order to help decide what we're going to render. So like I said previously, we can put JavaScript literally anywhere in JSX. What we did previously was put it on a style tag. Here, what we're going to do is we're going to put it literally inside the content of our paragraph tag. So normally what we would put inside of a tag is simply text, and then that text gets styled depending on what CSS we put into it. But here what we're doing is we're going to determine what that text content is based on the result of some JavaScript execution. So I've created a method here that returns roughly 50-50 true or false. And depending on what it is, we display heads or tails. So we're essentially just flipping a coin every single time that the page renders. And another thing we could do is we can insert it into the outside of a tag so that we can determine whether we're going to actually render that tag when this component renders. So what we're doing here is we're going to wrap it in curly braces to say this is a line of JavaScript. And then we're going to create a Boolean condition here, which again is just a function that we're calling, which will return true or false. Maybe we have some really complex logic here to determine whether or not we should return true. And then depending on the result of this, we either render the tag or we render nothing. And null here is not going to cause any errors for your website. It simply means that there's nothing that's going to be returned by this little JavaScript snippet. So it's not going to cause any problems. If you're confused about what this question mark is, it's something that is extremely useful in a lot of programming languages, not just JavaScript. As Ethan had said, yes, this is a ternary operator. JavaScript also calls it a conditional operator. And what it does is it lets us just write an if statement in line. So essentially what we're saying here is if this condition is true, we render or we do this thing, otherwise we do this thing. And in the case of JavaScript, that's rendering an element. Yeah, ternary is extremely awesome. All right, another thing we can do with JavaScript is we can specify values to our properties. So normally a property would take a specific value, so maybe a string, but what we can also do in this case, since hidden takes a Boolean, we can specify that Boolean with a line of JavaScript. So we can call a function that returns true or false, and then that goes into hidden. So this works the exact same way as our other method that flipped heads or tails 50-50 or conditionally rendered something 50-50. In this case, the hidden property determines whether or not it's going to be inserted into the web page, and half the time it will, half the time it won't. So lots of ways of doing the same thing. There's no correct way of doing it. I just want to show you all the things that you can do with JavaScript and JSX. Okay, and the fourth thing is that we can pass custom properties to our components. So this is where we start to actually get to some really cool things that we can do with React. The whole point of React, keep in mind, is that we want to make our web pages really dynamic and have them be able to change as we do different things with them. And so it seems useful to be able to pass data into our components from other components so that those components have new pieces of data every time we interact with the website. So what we can do is we can pass values from parent components to children components. And we do that through something called a props object. So it basically bundles every single property we put onto that component tag into a JavaScript object, and then we can unbundle it as needed. So props are accessible by calling the props object and then simply getting the name of the property that we want. So in this example, we have a parent component here. And when we're rendering our child components, we pass in two properties that we have come up with ourselves. These aren't natural HTML properties, text content and text color. And so what we can do is in our child component, where these properties have been passed in, we can simply extract them from the props object. So what we're doing is we're taking the style and we're making the text color our text color property, and we're making the content our text content property. So we can make it a little bit more flexible. We can determine what values we want our component to render from the outside. So keep in mind, we can pass data of any type through the properties. What we had done previously was pass numbers and Booleans and strings, excuse me. But we can also pass function references. And we're going to go over a quick demo of why that might be useful, but it will become a little bit more clear once we get into state, which will come a little bit later. But what we can do is we can essentially execute a function in a parent component from our child component. So maybe what we wanted to do was kind of abstract away a form and have a component for each element of our form. So we have an element for the input for a name and an element for the input for your email. And then we also have an element or component for our button. Well, the button doesn't have access to everything. The parent does, though. So maybe we want to have the button be pressed and then execute something in the parent so it can interact with the other components. Well, we can do that with function references. What we're doing here is we're creating a function in my parent. And again, it's an anonymous function. We're assigning the reference to a variable. And then we're passing in that function reference to our child component. And the child can then, from the props object, take that and execute it. You'll notice here, we are not including parentheses in the function reference that we're passing in here. We don't want to do that because otherwise JavaScript will say, hey, that's a function. I need to execute that function. And it doesn't. We don't want to execute the function out here where we're rendering content. We want it to be executed on the inside when this component decides, the child component decides that it needs to execute. So all we're doing is passing in the reference to the function. We're not executing it. We're executing it in the child when the button is clicked. So adds a lot of extra flexibility for how we can handle different things in our components. Another thing to be aware of is that it's a property object. And in JavaScript, if you try and access a property from an object that doesn't exist, you'll get an undefined value. And sometimes this can be useful. Maybe you want to pass in a property only some of the time if you have it. And if you don't have it, you don't want to pass it in. In that case, in your child component, you could check to see whether a certain property is undefined, which means it wasn't passed in, or if it is defined, in which case you use it for something. But also sometimes you may have forgotten to pass in a property in one specific use of your component, because again, we don't have to use our components exactly once. We could render a component in here. If we had another parent somewhere else, we could render it in there as well. We could render 4 of them in a row here if we wanted to. Maybe in one of those cases you forgot to pass in the props value, in which case when you try and use it in your website, it'll be undefined. And that's a little bit of a bug, and you'll have to track that down. Okay, and last thing I want to talk about with properties here is the concept of class properties or default properties. We don't have to pass in a value to a child component if it's going to be the same every single time. Instead, what we can do is we can define a default property for that component as a whole. So in this top example, my component has a props object and we're using different things from it, but we're specifying a default prop of default color, which means every single instance of my component is naturally going to have the property default prop or default color attached to its props object, and we can just access it here. And you might be asking, well, what if I don't want to use that default value? Well, it's very easy to get around it. All you have to do is actually pass that property when you're rendering the component. So if we passed in default color here, then it overrides the value in our default color, which is originally pink, and now we have a green square. So a lot of flexibility there. It will help you from having to pass in the same value for the same property every single time, if that's something that you're doing. Okay, and now is the big topic that we want to talk about. This is what makes a web app an app. If you're writing in just base HTML and CSS, there's a limit to what your website can do because it can't really manage anything super interesting. It's not until you introduce other languages, other frameworks, that you can start to really manage the state of your application, how the user's interacting with it, and pass data around to make it interactive. And so that's the main reason why we use React. So let's talk about the concept of state. So all of our previous examples would render the exact same thing every single time, which is not really helpful. We want it to be able to render different things depending on how our application is currently being used. And all of those examples would not re-render unless we manually went up and refreshed the page, which is also not useful. We want the page to be able to update when it needs to when we have new pieces of data. And both of those things we can fix by introducing state into our application. So component state is simply data that belongs to a particular instance of that component. And what is that data? Well, it's whatever you need to store in that component in order for your application to be useful. There's no predefined state in any component. If you work with something like Flutter, or if you worked with React, you'll have heard of the concept of stateful components / widgets, or stateless. Stateless means we don't naturally have any state housed inside. So it doesn't have any data that it's managing. And by default, that's how all of our HTML elements are. They simply render to the screen. They don't do anything special. If we introduce state to our component, now our state can handle data. And when that data changes, React knows, oops, well, this component's not the same anymore. I better refresh it so that the user can see the update version of this component. And so if a component state changes, the component and all of its children that are dependent on that state are going to re-render. And it's not going to re-render everything. It's only going to re-render what you, the programmer, have defined to be dependent on a particular piece of state. So you're not going to re-render the entire web page every time. If you have a really complex website, that would take several seconds in order to refresh even once. Instead, it's almost instant, and it only refreshes what's important. So another thing that we talked about previously was the concept of passing function references. It gets really useful for state because state is housed inside of a component. So a component has its own state that is unique to a particular instance of that component. If we have lots of the same component, they may have the same state variables, but they'll all have different values depending on that component's current state. So what we can do is if we want a child component to be able to interact with a parent component state, well, we can use function references. And the function can be defined in the parent to interact with the state of the parent. And then the child can call that function from inside of itself. Naturally, we can't pass state and make it accessible to other components. We have to do that through function references. So again, state is housed internally by React, which means you yourselves do not have to manage it. You do have to find ways of identifying to React, what state do I need, and what function am I going to use to update it. So with functional components, that comes through the use of something called hooks. And hooks are JavaScript functions that, according to the React website, are functions that let you, quote unquote, hook into React state and lifecycle features. By lifecycle features, what we mean is the lifecycle of a component as it's being used in the website. So components aren't always going to be on your website. Maybe sometimes they start off and then they get put on later on, or as you move to different web pages, then different components for those web pages are going to be added and removed. So there's three main lifecycle events and a couple of different breakdowns from even those that we're not really going to get into because those aren't super important for functional components. But essentially, the three lifecycle stages we have to be aware of are mounting, which is when we insert an element or a component into the DOM for the first time into our web page. Refreshing, where we've already inserted it and it simply needs to update to a new value because our state has changed. Or unmounting, where it's being taken out of the web page and it will not be involved anymore with how the DOM is being rendered. Class components do not use hooks for managing state. Instead, what they do is they use a method where you can specify a new object and it merges it into the state object for that component. And it's very verbose, and it's something that we don't have to worry about with functional components. Now, the reason why we don't do that for functional components is for extra flexibility. So a couple things that you can do with hooks that you can't do with class component state is you can share some of the logic related to your states and updating states with multiple components a lot more easily than we could do with class components. Because again, class components state is internal to that, and you have to call a method in order to have access to it. Hooks get you a little bit more flexibility in how you interact with it and how you update it. It also lets you split up unrelated logic for the same lifecycle event into several different places. Something that we'll talk about a little bit later is that class components, essentially, if you want to execute code at those lifecycle events, so again, mounting, updating, or unmounting, class components let you implement functions that trigger at a very specific time, and all of the code you want to execute at that time has to be in the same function. Which, if you're doing lots of different unrelated things, that gets very messy very quick. So instead, what we can do with hooks is we can create hooks that execute at those same times, but we can split it up into lots of the same hook. So maybe one contains logic that does the same thing, and then another one contains logic that does something totally different. It's a lot easier to manage singular little pieces of your application, and it's a lot easier for debugging and for development. It also, we don't need to learn the use of classes in JavaScript. There's no classes involved in functional components, and so we don't need to worry about lots of sort of more difficult JavaScript class operations, especially like the keyword this, which gets very crazy very quickly. There's none of that with hooks. And then the last thing is it's simply less verbose. We'll do a comparison of that very shortly. Okay, so I talked a lot about hooks, but I haven't even told you what a hook is yet. And essentially, all we need is to implement a specific kind of hook. So we're going to look at one hook right now, which is the useState hook. So useState lets us declare a new piece of state data that we want to keep inside of a component. So essentially, it's a function that is defined somewhere in React, and we can pass in an initial value, which says, okay, so if this component is being rendered for the first time, we're going to create a new state value and give it initial value. Otherwise, we're just going to take the state value that's already in the component, and then it will return to our function two things in an array. It will return a state variable, which we can name literally anything we want, and also a function that will let you set a new value to that variable. And again, we can name that function whatever we want. So what you'll notice here is that this is something called the array destructuring syntax. The return of this useState function is an array of two elements. The first one will always be the variable, and the second one will always be the function. And so what we're doing is we're essentially saying, okay, so I have an array of 2 elements, and I know it's 2 elements. So we're going to declare 2 variables that are constant, and we're just going to take what's in each index of the array and stick it right into the variable immediately. So we could also put the result of this use state into just a singular variable and then have 2 more lines that set new variables of each index of the array, but that's 3 lines when we can do it in 1. So why would we do that? And here's an example of it being used in practice. So if we were taking a functional component here and we just want to make a very simple application that lets you click a button and keeps track of how many times we click it, we need some way of, between the number of times our component is being rendered, keeping track of how many times our button has been pressed in total. And we can do that with the state of our component. So what we're doing is at the very top of our component, we're going to create a new state value, which is count, and a function that sets a new value to count and our default value of 0. So if this component is being rendered for the first time, it's going to be rendered at 0. And then what we're going to do is we're going to create a new method here that when our button is pressed, it calls this function. And it's going to use our setter function, our set count, and it's going to simply increment it by 1. So we take whatever our current state value is in count, which will be a number, and we're just going to add 1 to it and then stick it right back in. And what we can see is that if we do this, it's pretty simple. All we're doing is displaying the current value of count when this component is being rendered. And if we click it, it updates the new state value. And like we said previously, when state updates, React knows, okay, this is different. Now I need to re-render this component. So every time it re-renders, it's going to call the whole function again, our functional component. It's going to call again. And what it's going to do this time is it says, okay, we need to create a state value. Oh, well, we already have this particular state. So we're not going to use our initial value. We're simply going to return to count what our previous state was, and then the function to set it again. So if we started at 0 and clicked our button once, when it renders again, count is now going to be 1. And then if we click it again and it re-renders, it's going to be 2. So our application will automatically update itself when it needs to, and we don't have to click any refresh buttons. We don't have to do anything. All we do is click the button, click me, and then this number will increment by itself. And we can make the exact same thing as a class component, which I didn't talk to you guys about the syntax of class components because I was going to initially create this presentation using class components, and then pretty much everyone brought up to me that there's no point because no one really uses them anymore. But if we were to do this with class components, this is all the code that we would need to do the exact same thing. And again, I mean, there's 5 extra lines here from comments, but it's still a lot more code to do the exact same thing. So functional components help make things a lot simpler. Just requires a little bit more understanding about how JavaScript works and how everything's happening. Okay, so there's a couple of pitfalls that you definitely need to be aware of if you're creating a React application and managing state. State is preserved between renders. Variables that you declare in the function are not. So if we go back here, we're creating a variable for this function reference. And every single time this component re-renders and our myComponent function is called, this function is going to be recreated and then stuck into the variable here. If we simply had a variable that stored some piece of data, it would reassign that data, our literal value of the data, to that variable every time the component is re-rendered. And if we changed it somewhere down here, that would not be updated. If you want a value that's going to preserve between re-renders, you always need to make it a state variable. If not, you can make it just a local variable. The other thing to note is that state is not guaranteed to run right away. React does a great job of performance optimizations. And one optimization is including lots of state updates in a singular update. So it will run your execution asynchronously, which means it doesn't run it literally the line that you're calling it. It'll run it a little bit later when it determines it's a good time to run it for performance reasons. And because it doesn't run immediately after the line that you've requested the state update in, you can have multiple state updates in a function and expect that React is not going to update until you get to at least the end of the function. So don't expect if you write like multiple state updates in a row that it's going to literally refresh the component every single time that you call one in between each one. It's not going to do that. And the other thing to note is that you absolutely need to use the setter if you're going to update state variables. The setter is what lets React know this state has changed and it needs to re-render. If you don't, it will be buggy. Maybe it will do the thing that you want it to do. We're going to look at a case of where it kind of does, kind of not in just a second. But if you want to guarantee that it's going to update, which you should, because that's the whole point of using state, you always need to use the state setter. Okay, so let's take a look at an example of where things get a little bit buggy and why you should just use the state setter. If we have an array in our state, so we can store any data in state we want. We can store a number, a string, we can store an array, we can store an object. We're going to practice with an array here. And let's say that we created our application to simply store a list of numbers, and every time we click a button, it's going to generate a new random one. Pretty easy. So what we think that we can do here is we can take our numbers array and simply push a value in, because the array isn't changing, right? If it's state somewhere housed, we can just stick on to the end of the array. And you would kind of be right. But because we haven't used our setter function, React doesn't know that a change has been made, and so it doesn't cause a rerun. If instead of using our example here, we caused an update for another reason, so we're going to force an update here by setting a different piece of state. That we would probably not want to do this in practice because you shouldn't need to. But if we, for some reason, re-render a component for another reason, then we'll notice that the number does actually appear when we refresh our component or when we refresh the page. So pushing to an array does actually change the array, but it doesn't cause a refresh because React doesn't know that's what you're doing. Okay, another thing that we would think might work is by simply using our array and adding to it and then sticking it right back in with our setter function. You would think that would work. And again, it kind of does, but it kind of doesn't. So this will also not cause an update on the screen. And if we force an update for another reason again, then we'll notice that it does actually appear on the screen. So it did actually push the value successfully to numbers. And the problem here is that even though we're using our setter function, if we use the exact same numbers variable here, then it's going to assume that it's the same array and it's not going to update. When you have literal values like strings and numbers, that's not a problem if you perform operations on those because it creates a new literal. But when you have an object or an array like this, if you don't create a new object or an array when you use your setter, then React doesn't think that it's really changed, and so it doesn't cause an update. Even though, since we pushed a value, it has actually changed. So the correct way of doing this, which seems counterintuitive, is actually to simply create a new array and then stick our value on the end of that. So this is another little JavaScript trick that we're going to use. This is called the spread operator, our 3 dots. What we're doing is we're creating an array in line here. So our square brackets say we're creating a new array. And then we're spreading out all the values from the numbers array into our new array. So all of the values and numbers will be copied. And then all we have to do is simply stick another value on the end, which is our new random value. And now if we click the button every single time, it will create a new value, stick it onto the array, and it will update. So that's the behavior we want. So again, if you're using a non-literal value, be careful to make sure that you're using the setter method with a new object so it updates every time. Okay, so we talked previously about component lifecycle, where we can have mounting, updating, and unmounting. And again, class components have functions that implement everything you do on that lifecycle. It gets very messy very quickly. Instead, what we do with functional components is we have other kinds of hooks. So our use state was the first kind of hook that we're going to use. We're going to talk about 3 other hooks that we can use and what they would be used for. The first one is called useEffect. A useEffect hook just executes a piece of code when our component is rendered again. And we can also specify something called a dependency array, which means we don't want to execute this code every time, but only when a particular piece of data changes. Usually, it would make sense to make that state data. So we can specify our state variable here, which again, this should be state up here. I declared this incorrectly. But we can specify a value here, and this useEffect is going to execute our function. So again, this is an anonymous function. We could specify, the whole function, name of the function, blah, 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 and then specify the reference here if we want to. But instead, we're just going to do it inline, create an anonymous function because we don't really care about the name. We're only using it here. And all the code inside is going to be executed if this value changes. We can put multiple variables in this dependency array. And if any of them change, then it's going to update everything here. Hence, the code inside is dependent on those values. And when those values change, then the code needs to execute again to perform some new calculation or something like that. We can also specify a cleanup function. So a cleanup function is something that's going to run when a component leaves the screen. So usually this is useful for if you have a subscription or maybe a timer that's being run, something that starts when a component first shows up and needs to end because you're not using it anymore when the component leaves. So inside this function, which again, we could specify a function reference that we've defined somewhere else, but since we're only going to use it here, we might as well just make it inline. It's going to execute this function when the component leaves. It's not going to execute it right away. It's going to execute it when the component leaves the screen, and it's going to execute everything on the inside. Okay, 2 notes down here that I just want to mention about all of your hooks, and I thought this was the best place to do it. Hooks on screen run in order from top to bottom. So usually what people will do is they'll specify all of their state hooks at the top of their component, and then all of their other hooks like useEffect and the other ones we're going to talk about below that, which usually depend on state values. If you particularly need one to execute before another, then you have to put it higher up in the component. Another thing is that hooks need to be top level in a function. So you should not have hooks in a loop. It doesn't make any sense. It will be buggy. It's not what you want to do. If you think that's what you want to do, figure it out. Do something else. Instead, what we want to do is keep it at the top level. Okay, another hook that we need to talk about is useContext, and useContext is helpful for passing values down really long chains of components. So let's say we had a tree of 40 elements. We could pass a value, if we have a value that starts at the very top and needs to be used by every single component, or maybe used by like half of them, but we don't know which half, then it doesn't really make sense to pass it through 40 components and make everything really bloated if we don't need to. What we can do is we can use a context, which is essentially a collection of values that we can subscribe to from children and we can provide from some parent. And that parent only has to provide it once, and then all of the children that need it can use the context that we provided by the parent. So this is an example from the React documentation. I personally have never used useContext, but I also have not been involved with I've worked on projects that have used context before. I just haven't been the one doing it. So it's absolutely useful. I just didn't have a great example to show you myself. So what we're doing here is we're creating our context somewhere outside of our components. And then our components here are functional components, which they're not using anonymous functions. They're using actual JavaScript functions. They're providing a theme value. And then where we need it, down here, we can use the context, our theme context, and then just pull out the values from that themes variable up here. So it's mostly used for theming, but you can also use it for lots of other things. Okay, last hook we're going to talk about is the useMemo hook. And also I'm way lower on time than I thought. So we're probably not actually going to have a whole lot of time to do the demo, which I apologize. I will provide you guys with some GitHub code, which you can use to look through and see what we're doing and run it on your own laptop and learn from that. And you can certainly ask me about it afterwards. But what we're going to do is we're going to use the useMemo hook. So useMemo is another function that React provides, and it basically computes something. It lets you execute a function if a dependency array changes. So it has the same dependency array as our other hooks, our useEffect hook, but it's only really useful for computing one very hard to compute operation that might take a lot of time or a lot of resources. And you don't want to do it every single time a component re-renders, which honestly happens a lot. Just because you press a button doesn't mean it's only going to render once. Sometimes it might render 5 or 6 times depending on what's changing. So we don't want to necessarily compute a really expensive value every single time. Instead, what we want to do is only compute it if the values it depends on change. And so what we can do is we can specify the function that we need to execute and then what it depends on, and it will calculate that value and assign it to a variable if that changes. One thing to note, don't do anything other than expensive value inside of here. Physically, you can, but it doesn't really make any sense. If you have something that's going to be executed on every single render or something that's unrelated that just happens on some occasions, put in a useEffect hook. You're not limited to just one useEffect. You can use as many of each of these hooks as you want. So create a new useEffect exclusively for that other little piece of code that's unrelated, and use the dependency array to determine how often it's going to run. That's what useEffect is for, just random little snippets of code that you want to run when things render. There's another hook called useCallback, which has the exact same function as useMemo. It just has a little bit of different syntax for up here. So if you see those two, they are basically the exact same. Okay, so this is where we would get to the demo, but we only have 3 minutes, which means I cannot even really get started on the demo. What I would like to tell you guys is that if you want to create a React application, the best place to get started is something called create React app. So there's a command that you can search easily, npx space create-react-app space, and then the name of your application. And it will automatically create everything you need for a base React application inside. There'll be lots of things that you will not understand what they are, but if you do some quick Googling or if you ask someone in the front end help, someone will absolutely be able to tell you what they are, and you'll be able to get started very quickly. I've taught you everything you need to know about components and about JavaScript and about React. Essentially, all you're doing with the React application is creating all of your components that will eventually render into a root, and then you can style them as you so desire. So you have all of the tools from this presentation in order to work on something. I would have loved to be able to actually show you in practice what it's like. I will absolutely provide you. Wait, I haven't done 1:30? Wait a second. All right, hold on. We gotta figure this out. What schedule are you looking at? Can you show me a link? I guess if there's nothing after me, then it really doesn't matter if I go long or not. Okay, sweet. Well, the session is only defined for 12 to 1. Victoria, while you're here, do you mind if I go an extra 15 minutes or so I can actually get to the demo that I had planned? Since you just showed up here. Awesome. Okay, forget all that. We're actually going to do the demo. So these are some links here. I'll actually just talk about them really quick before we do the demo because it's honestly unrelated. But essentially what I have here is lots of links that you can use in your project to make it more interesting. So React reference is the 2 top things here. So these are really helpful for if you want to learn more about specific pieces of React. And then also we have a list of free APIs here that you can use to do something interesting. Yeah, Victoria, if you could set it to close at 1:30, that would be better. But if you don't have a choice, just let me know when it's actually going to close so that I don't get stuck in the middle of something. Awesome. Thank you so much, Victoria. All right. So the other thing that I want to talk about here is something called component libraries. Creating components is a lot of work, and you have to style all of them. Base HTML looks like garbage. So especially in a hackathon where you don't want to spend 75% of the time trying to figure out how do I make this thing look exactly perfect. What you can do is you can use component libraries where people have already come up with React components and styled them to look awesome to do lots of different things that you would want to do. So Material UI is one of the most commonly used ones, and we're actually going to take a look at that really quickly if I can actually get out of this presentation. So essentially what a component library is components that people have come up with that you don't have to, and you can literally plug and play into your website to make it look much better. And you can customize it depending on how you need. You can add actions to it as needed. But if we look through here, basically what we see, actually, let's go back to the previous page here. All of these things that they're showing off in the corner here, sorry, this is really slow because Hopin seems to be using most of my Chrome tab here. This is very slow, but all of these things that Material UI is displaying over here are components. And these are pretty gorgeous. Like you can plug these in, you can style them a little bit to fit with your themings, but these are fully functional things that do things that you want. So these, if you wanted to have something that had tags, then you could create little tags here. There's navigation buttons. We can have lots of different input values, buttons. lots and lots of things that people have come up with, and you can literally just copy the code. Or actually, you don't even need to do that. Material UI is a npm library, so you can run npm install Material UI and then simply import the components you want and stick them directly into your rendering. We're not going to do that as part of the demo, but we will. I highly, highly recommend you check this out when you're working on your application as part of the hackathon. It is absolutely a great resource to have, and it's used literally in the industry. It's not like you're cheating or anything. I had an internship over the summer with Florida Blue, and almost all the components we wrote were from Material UI and just modified somehow. So it is not cheating. And then the other thing to keep in mind is that styling with base CSS is a lot. And it's very difficult to come up with rules that are effective, and you have to write a lot of rules. You can also use libraries that help you style a lot easier. Something that is going to be covered in a future workshop by Aileen tomorrow is Tailwind CSS. And this is something that I first got experienced with, honestly, just like a month ago, working on some of the projects for this hackathon. But Tailwind CSS basically lets you put all of your CSS into one string and abbreviates everything. So it helps you get all of your CSS up very quickly, and you don't have to write a bunch of extra code somewhere else in order to make it work. The downside here is that it is kind of difficult to pick up. Once you learn what things mean, then it gets a little bit easier, but it takes a little bit of time to figure out what things are. And then also, it does look a little bit messy. So that's another thing that I highly recommend you check out. If you're still around and have time tomorrow, I would absolutely recommend you go to that workshop in order to get sort of a head start on that. It's a great, great resource to have in your tool if you're doing any front-end design. Okay, that being said, we are on to the demo time. So what we're going to do, let me actually just open up our demo here. Okay, so I guess I'm sharing the whole screen. I thought I was just sharing a particular Chrome tab, but I guess I'm not doing that. Okay, and can someone just confirm for me that I haven't disconnected again? Because when I look at the People tab, it's telling me there's a network error. Okay, awesome. Sweet deal. Sorry, my internet at this apartment complex has a tendency to just spontaneously combust, and so I always want to check and make sure that everything works. So what we're going to do is we're going to pull out our editor of choice. I'm going to use VS Code. If you have VS Code is awesome. If you don't, you can use any editor that lets you edit any kind of file. Usually you want to use something that has syntax highlighting for the language you're writing. So we want to have something that can handle JavaScript, but you don't need it. And you're also going to need a terminal. VS Code has a terminal into it by default. We're going to use that, but if you are working on a different, if you're working on a different IDE or on a different website, sorry, not website, operating system, then you can absolutely use just the pop-out terminal, no problem. Okay, so what we're going to be creating here is an application that just does a couple of little things here. So we're going to start this just so I can show you what it does first. So we're done with that presentation for now. Let me just open Discord here and make sure that someone isn't trying to get a hold of me. Okay, someone was not trying to get a hold of me. Great. All right, so this eventually runs, which theoretically it should. Oh, no, it didn't, because I'm just in the wrong folder. Okay, so you shouldn't be doing anything right now. Just watch for a second. Essentially, what React apps do is they have lots of different scripts inside of them. And one script is start, which we run from the npm start. And we'll talk about where the scripts are and how you can see them in just a second. But if we call our start script, it builds everything in the React app and then runs it in your browser. So we're going to do that to see how things are here and help for some local development. There's lots of other ways that you can configure your scripts to operate depending on what you need. I'm not going to get into any complicated things there just because I'm not really an expert in it, nor is that something that's useful for what we're doing. Okay, theoretically, it's getting closer. We have new text here that says starting the development server, which I think is good. All right, sweet deal. We are in business. So let me make this a little bit bigger for you guys so you can see what's going on here. Can I not zoom into VS Code? I feel like I should be able to zoom in. Deal with that later. All right, looks like something zoomed in. Sorry, I'm running off of a laptop, which is not particularly powerful. It's okay, but I'm running a lot of things here, so it's going to run very slowly. Yeah, I know that you can zoom into VS Code, and I think I did a little bit. It looks slightly bigger than it did, but it's going so slowly that I can't actually tell if it's doing anything. All right, I'm about to give up on this. Oh no, here we go. So eventually it'll say that it compiled successfully, and there we go. So we have a very basic thing here. I haven't really done any particular great work of styling, and we're actually going to make it even less styled than it is here. But essentially, we have two different things we're going to do. So one is to demonstrate how we can use API calls. So this API I found online, and it basically just guesses your age based on a name. So if we put our name in here and make the API call, it's going to guess that I'm about 30. Spoiler, I'm not 30. And I assume counts how many times people have looked for the name. I honestly don't know. And another thing is we can create a basic to-do list here where we can create to-do items based on the values we put in here. Okay, awesome. Control plus equals. All right, I think this is big enough. You guys can all see the letters on the VS Code, which is all we really need here. Okay, so we're gonna keep this browser on the down low for now. And everyone needs to go ahead and open up your command line. And we're going to, I'm gonna back up quite a bit here. Okay, so by default, when you open your terminal, it's going to be somewhere, and you can choose where you want to house your project, but you need to go there through the command line. So we can use the command cd in order to go to a particular file. And I'm just going to check really quickly what I have in here. Oh, wait, this isn't Linux. Okay, so I can't actually tell you exactly what the command is, but if you basically you just need to pick a folder where you want your React app to be created and then open the terminal there. So I'm going to navigate back to exactly where I was, / React workshop code base. And then, okay, so this is where I'm going to do mine. So once you're in a location where you want to be, we're going to, assuming that you have Node installed, Node should have come with the Node package manager. And with the Node package manager, we also have something called npx. So if you run npx and then -- version, oops. Oh my goodness. Okay, let's try that again. So if you want to check and see if you have these installed, you can always run -- version after something. So check and make sure that you have npx. It should come by default. You shouldn't have to do any special installations. And if you do, what we're going to do is we're going to run npx and then a space create and then create React app. So those three words are going to be hyphenated. And then after that, we need to specify the name for our React app. So we're going to write this as demo project. And it's going to go through a little bit of process creating our application for us. Oops, I guess we can't use capital letters. So in that case, we're just going to make it all lowercase. And so this is going to go through a bit of a lengthy process. It'll ask you a couple of things probably of just various things for configuration. It shouldn't take a couple minutes. It should only take a couple of seconds, maybe 30 seconds or so. And it's going to come up with everything that we need for a React application by default. So we won't have to create a bunch of different stuff in here. Once you get a little bit more advanced, you can absolutely use different templates. You can use different libraries that will compile your React application, but we're not going to deal with that because honestly, Create React App is pretty much all you need for getting started. All right, this is definitely going to take a while because I'm streaming, and so this computer is going to take quite a bit. Let me see if I can close a couple things here that we don't need. So we don't need this browser. I don't need this. Do I have any like crazy processes running or something? Let us check. I'm gonna open Task Manager for myself really quick, which actually is just gonna make everything worse for a second. Okay, I'm gonna let this go. Some of you probably will have already finished it by now. Unfortunately, there's nothing we can do in the meantime. So we just gotta twiddle our thumbs a little bit. And once we get into it, we're going to talk about all the different pieces of a React app that you're going to need to know. And then from there, we can get into some actual programming, which would be awesome. Okay, these should not be here. And this should also not be here. I did something bad earlier. It appears. Okay. Awesome. If you got happy hacking, that means you're in business. Hopefully we'll get that very shortly. And when you're finished with that, go ahead and open up the base folder in whatever IDE you use. If it's in VS Code, you can open that up, or whatever IDE you prefer for this demo. All right, awesome. So we got our happy hacking somewhere over here, maybe. But if we see something about a bunch of packages being funded, vulnerabilities, stuff like that, that means we're in business. So lots of things created here that you need to be aware of. All of our React applications start at the base level with a bunch of different folders. So one folder is called node_modules. Node modules is all of our NPM packages that we've installed for this particular application. With Create React App, it installs a lot of them by default. Oh, I guess it's not actually done, but we can at least start talking about it. We can install lots of other things as we need them. We're actually probably not have time to get to the React router, which is how you handle multiple pages. If you want to do that, you absolutely should look into that package. But we could install that through a command, which actually we'll do just for the sake of it, even if we're not going to use it. So this is where all of our things get stored. You're not going to be interacting with node modules in particular. That's something that React handles for you in NPM when you install new packages. And then the other thing is the public folder. Public is where all of your files that are public to everyone are going to be able to, find. So by default, it includes some stuff that's for a base HTML page. So lots of different things that are required for defining an HTML page. And then eventually down here, we have our root elements, which is where we're going to insert all of our React elements from our JavaScript. So all of this stuff we don't actually need for the demo we're going to make. We can leave it for now if we want. It's going to be used by some of our other stuff, which we're going to find in the source folder. We'll talk about the source folder last before we jump into things. It also instates a Git repository by default, which is where the README comes into play, and then the git ignore. So README just tells people on GitHub, what is this repository for? You'll have to hook up the repository to your GitHub account and push it before anyone can actually see this, but it is in there by default. And then git ignore is a file that tells Git what exactly it is that you don't want to send online when you push to GitHub. And usually that's anything that's private or anything that's really big. Node modules is really, really big. Packages are very large, and Create React App has a lot of them. So by default, node modules is in the git ignore, and we don't want to take that off. Lots of other things are in here that you probably don't want. Production builds are also ignored. If you wanted to put your app into production, you could set up lots of processes for doing that. And all of this stuff by default. .env is a way of storing data that's going to be used by a process that you're running. And so that also is private. You don't want to pass out the values of those to everyone. So that's also something that's ignored. But we're not going to mess with the git ignore either. We're going to leave everything as it is. And instead, what we're going to mess with, actually, never mind. I guess I have to talk to you about the package and package lock too. So package.json is how React determines all of the configurations for your React app. So some of these are pretty obvious. So this is a JSON file, which means everything is a JavaScript object. And some of this is obvious. So the name of our project, which we named with Create React App, our version, whether or not it's private, which means it's published as an NPM module to other people. And then dependencies. And dependencies are the libraries that we require for our thing to use. We're not going to touch most of these, but these are all what comes by default. And then we have scripts. Like I was saying earlier, you can create a lot of different scripts for your application to run that do different things to set up for your application. If you're involved with deploying things to production or creating a more professional application, then you definitely would want to mess with the scripts a lot. And then some other stuff down here that basically we're not going to use for anything, and it's just extra configurations. Okay, so package lock is also something that you're not going to write in. Package lock is generated by React every time that you install a new package, and it basically just gives a configuration of everything that is stored and all of the versions that it needs. This does get committed to Git so that everyone who's working on the same project has the exact same module setup. It's going to be specified in package lock, and then when someone runs the command npm I, it's going to install all of the modules in the package lock that the person doesn't have, and it's going to remove anything that they don't have. So it's going to synchronize everything between every person that's working on the code base on different computers. That's why we have package lock. So that also you don't interact with directly. So let's figure out how we could add a new package to React really quick. We're going to add the package React Router, which is how we would handle different web pages together. Again, we probably won't be able to get to that in the next 10 minutes, but what we can do if we want to install a new dependency is we can run the command npm install, or you can do npm I, it's the exact same thing, and then we specify what package we want. So we're going to specify React-router, and if it can find the package, it's going to update and install the highest version of React Router that it physically can with all the other things that you have installed. So very quickly, it's able to do that just because it's one package. It's going to add it to the package lock automatically. It's going to add it to the package.json automatically. So you won't have to do that. Let me just make sure that it actually added. Okay, so it added to our package lock. It did not add to our dependencies here. So the other way of installing things is we could specify in here React Router. And then if we look on npm, the website, we could find a version here that we want. But we're not going to do that for now. We're just going to stick with npm I. We're also going to do npm I React Router DOM, which is another package that is very, very interrelated and is also required for handling routes. Again, we're probably not going to be able to use any of it. I'll post the full code afterwards where you can see how it's used. Okay, so let's get into the source here. So a lot of this stuff is just what comes by default and what React has decided to give you. If we loaded up our npm site by default, it would just have a little GIF of the React logo spinning, and then it would style everything a little bit. It's very, very basic and very bland. We don't really need any of that. And what we can do is we can get rid of some of the stuff that we don't need. So the main process of execution is that our index.js is what is the highest level. And so this is our render function that tells us, okay, in the root, we need to render our app component, which is going to be our base level component. We're going to keep the app component and just put some other stuff in it. But this web vitals function down here is a way of measuring performance of your application, and you can do stuff with that. We're not going to deal anything with that. So if you want to delete it, you can. We're also going to get rid of some of the other things in here that we don't need. We're not going to use the React logo that they're using. We already said that report web vitals is something we're not going to use, so we can get rid of that as well. Another thing that you can do with React websites is you can set up tests, which test your components in different properties and make sure that your components are working as possible. If you've ever worked with test-driven development, you can absolutely integrate that with React very easily. And it's recommended that when you're creating a bunch of components, you do that. We're not going to touch that today either. All right, so we're actually just going to cut out the CSS files as well. We're basically just going to start from scratch. So the only things we're keeping are index.js and then also app.js. And so now what we can do is we're going to have to take out some of the stuff here that we have deleted. So we have to take out the imports from our app.js because those no longer exist. And let's make our render from app.js empty. So we're just going to take everything out of the render function and instead just leave it as a div. And let's make sure that nothing in here. We also have to delete index.css, which we deleted, and everything else in here looks good. So if we want to test and see what our application looks like, we can run npm start, which again will take a very long time, so I'm not going to wait for it. But if you run npm start, it'll bring it up in a browser. Oh, what did I do? I just didn't go to the right folder. I am a genius. I already did this. Okay, so we have npm start, and we're going to let that run. Eventually, it'll pull up in a browser, and when it does, I'll show you. It's going to be blank. Yours will probably run much faster. The nice thing about npm start is that it basically refreshes every time you save a change in a file. So you only have to run it once, and it will continuously run in the background. And then you can edit things in your terminal, and then save it and swap over to the browser and see what changed. So it makes things a little bit simpler. You don't have to constantly wait for it to start. Okay, so let's actually add some components in here. So like we said in our index.js, our base level element that we're rendering, React strict mode is something that React uses. It's not an actual component that we see, is the app component here. And actually, it looks like my browser is going to pull up in a reasonable amount of time this time. So I will split screen for you guys really quick, just so you can see what's rendering over for me. Okay, so what's rendering right now is literally nothing. We've taken everything out of our application. So let's maybe try and really quickly implement a very simple to-do list. So what we're going to do is we're going to go into our, let me just make sure I'm in the right one. We're going to go into our app.js, which is our base level component, and we're going to create a form element. So a form is an HTML tag that we can close with another form tag. And what we're going to do is we're going to specify what we're going to do on the submission of the form. So onSubmit is a property for a form element, and we're going to give it a function reference of a function to call, and we're going to create our function up here. So we'll create a new function, handle submit, make it an anonymous function, and then we'll implement this later to do. And inside of our submission, well, we can now tell it that we want to handle the submit. Okay, so this will resolve all of our errors. If it shows you that module build failed, it simply means that you have to refresh the page for it to work. And again, we can't see anything because nothing's here. So let's add some stuff to our form element. So we can add an input element, and we'll make this type of text, which simply means that we can only type characters into here. And we'll make a name for it, which is name. So we're going to let someone type in their name here. Input elements by default should not have anything in them. So we can either close it with a closing input tag, or we can self-close it. And you'll notice that now we have an input element here, and we can type stuff in here. It auto-completes by default, and we can type in whatever we want, which is awesome. And let's make a couple more of these just so that we have them. So let's also make one. Oh, what have I done? Let's also make one for a, I don't know, last name. So this one could be first name, this one could be last name. And then we can also make one for a description, because all of our events need to have a description, right? All right, so what we can do is we can create state elements that handle the values of our inputs. So let's make one really quick just to show you how we would handle it. Let's maybe make a name value and a set name state, use state, and our default name is going to be nothing. It's going to be empty. And what we can do is we can control what value is in our input and update it using the value property. So our value is going to be whatever our name state is. And then on change, we can specify in here that we want to set name to be actually, we should not do this. So what we would do here is we would want to create a separate function. All right, I definitely do not have enough time to do this whole demo. I should have come up with a better way of doing this, so I apologize for you guys. But essentially what we would be doing here is based when our state changes, we would call another function that we define, and it would take from the change event. So if we created a function handler here, handle change, essentially there's a property here that we didn't use for handle submit that we might, which is the event that's being called. And so we can call event.target I forget exactly what the syntax is, but we can extract the value from this element and set it into state. So that way we're controlling what value is going to be in there, and every time that changes, we update the state of our component. And based on that, we do lots of other things. When we submit our form, we can pass that data to another component. Lots of different things that we can do. Okay, I have one more minute, so I'm going to get caught off in a second here. Thank you guys so much for sticking with me. I'm sorry that I couldn't get to the whole demo. I'm going to post as soon as possible on the Discord a link to a full set of code that you can look through the full application, which is on my GitHub. So, all right, have a good night, everyone. Stay safe and happy hacking.